Hi everyone. Today's teacher thoughts are about science. Now, similar to math, some of you may hear the word science and shudder in fear. You may picture your high school chemistry teacher and the physics lesson you never quite understood. Some of you really love science, but occasionally some of us have a pretty negative experience and that happens to translate down. So similar to math, science is so fun, and you're already doing a lot of things that would be considered parts of early childhood science. It's just a matter of putting it all together and sort of labeling it and showing everyone the great things you're doing that are already science related. When you think about science, there are some things that you would label as being a great part of early childhood science and some things that you would want to avoid. So just so you know, I have not really a handout, but I guess like a handout to go with this video because I had to look up a lot of things and I wanted to make sure you had everything in writing for you too. Okay, so I'm going to give you some words and let's see if you think they would be applicable to early childhood science or if they would not be, okay? So if you think of cause and effect, you try something to see what's going to happen. Yeah, so that'd be a thumbs up. That's part of early childhood science. How about hands off? Very like, you stay over there, I'll show you the museum display, you stay back over there. Nah, not so much. Well, there are a lot of really cool things that we show kids that they can't touch. That's just a tiny part of something. So if you have something they can't touch, it should be this big because they need to get in there and touch it. How about flexible? Do you think science is flexible? So that would mean maybe that you'd have an idea, you have a plan, and then maybe a child has a different idea and you kind of roll with it? Yeah, science can be very flexible. I always say the kids have way better ideas than I do because they have like the what if I try this sort of idea that I never thought of, and it's so much fun to roll with their ideas. What about compartmentalized? So that would be when we have middle school, the kids travel from class to class. They go from Bible, and then they go to math, and then they go to English. So that's more compartmentalized. What do you think about early childhood science? Should that be compartmentalized? So these 25 minutes of the day have to do with science, but no other part of the day? Not quite as much, right? Because science can be integrated into your whole day. There's so many neat science explorations you can figure out at the art table or on the playground. Even sometimes walking up the stairs, you notice things and how things work, and that's all a part of how exciting early. You also may think that early childhood science doesn't apply to you. After all, you don't teach 5th grade. Goodness gracious. But guess what? Science is all around us, even in the infant room. Especially if you think of science as starting with things like cause and effect and that whole, I wonder what's gonna happen thing. You could easily look at the infant room and figure out every time they dangle that sippy cup off of the tray table and they look at you like, I wonder what's gonna happen. Is she gonna catch it? Is she gonna get me? What's gonna happen? Every time they dangle that fork off the side and get ready to drop it, they're doing cause and effect. We may find it annoying as adults because they keep doing the same thing over and over again, but what they're really doing is experimenting with cause and effect. So I wanted to go over some of the process, the scientific process. We used to have a science fair in middle school. We haven't had it for a while. And in that process, we would teach the kids how to do things like form a hypothesis, which is like a guess, and then test it out and change some variables. So really when you're doing science in the classroom, it is along the same lines. So I wanted to show you first, I have my little notes here, so sorry. The scientific process is not a cut and dry kind of thing. There's no like certain way you have to do it, but generally here are some of the steps that you would see in an early childhood science experience. First of all, there's a question. I wonder what's going to happen. Or, I wonder why it rains. I wonder why flowers are a certain color. I wonder why, right? And older kids can verbalize that, and younger kids just sort of keep testing things out and trying it. And that testing process can look like a behavior problem sometimes, but really, sometimes what they're doing is just testing out some cause and effect. So the first thing of the first part of the scientific process is, I wonder. You're wondering about something. The second part is to observe. So you can guide kids. Well, I don't know why or how plants suck up the water. Let's figure it out together. Let's watch some plants. Let's try some things out and see what to do. Then you make a guess. Maybe a child would think something like, I think that plants get water because they have a straw inside them. Okay. And even as an adult, a child makes a guess that you know is not correct. We want to allow them the opportunity to explore and to test things out. So here comes the next part of the scientific process. Test it out. This is when they get their hands on things, touch it, feel it, experiment with it, try it again. Then they can talk about what happened. The ice is melting in my hand. I wonder why that ice is melting in my hand. If I'm a big person, I could talk about myself. If I'm a little person, I have an adult narrating for me. So if I'm a little person, I could say, ooh, Megan, that looks cold in your hand. Is that ice cold? Now the ice is melting. Look at it dripping on the floor. And I would narrate and talk about what's actually happening. Then another fun thing to do is to try it out again and change something. So if I'm going to play with plants and I want to figure out if the stem is really like a straw and I can't quite figure it out how I did it the first time, let's try it again. What else can we try? This time, let's try some colored oil. Would that help? Or some colored water? Let's set up an experiment where we can test out how plants will drink their liquid. So the first part is a question. I wonder, The second part is an observation, talking about things that they see and they notice. The third part is making a guess. I think that... The next part is testing it out, trying it, playing with it, experimenting with things. Then you talk about what do you notice? What's happening as you're testing things out? And then lastly, try it out again and change things. Those are called variables in Big Kid Land. But try it out and change things. So here I have some jars of water and some carnations, and I want to talk to you a little bit about the difference between a science demonstration and a science exploration. The difference between a demonstration and an exploration. If I bring this into class how it is, I brought a glass jar, and there's no way I'm giving these guys a glass jar. So at circle time, when we're together as a group, is a good time for a science demonstration. And you could still go over the scientific process. So for example, if I brought these flowers in to circle time, first I would say, I wonder how all that water goes in the plants. I wonder how that happens. And we would talk to the kids about, what do you notice? What do you see? What are the parts of the plant that you see? Then we would make a guess together. I think that, and maybe they think weird things like, I think the flowers go to the grocery store. Who knows? Take all of their guesses. Then we want to test it out. Now, as a demonstration, we're going to have to test this out together as a group because I don't want to give them my glass jar. And it doesn't happen very fast. This is the old experiment where you cut the bottom of the white carnations and put it in colored water. This doesn't happen right away. So this is more of a demonstration. We can still guess about it and make hypotheses. We can try to figure out what's going to happen. But we're going to do the scientific process all together at circle time, make our guesses, and we're testing it out, but we have to wait a while, and that's okay. However, if I wanted to take this demonstration and turn it into a center experience, I would first make sure I give them materials that are safe and child appropriate. So I could save some plastic jars to play with instead of the glass ones. Now, something like a flower experiment, that takes a really long time. It's really hard for kids to wait on that kind of thing. So I wouldn't put that in a center because all you would do is stare at it and nothing would happen. In a center, you want to make sure it's hands-on. You can touch it, you can feel it, you can change different variables. So if I were going to be putting if I were to be putting a carnation experiment into a learning center, I have to make sure it's independent for the kids to play with. So it's not going to work the same way it's going to work at a demonstration at Circle. It's just not going to work that way. So there's a demonstration, which is things like volcanoes exploding. Those are cool, but it's over pretty fast, right? You can't change a lot of things. When you have something at a center, you want to make sure there's opportunities to change things for the kids to test things out. So if this was a center, I would give them some droppers with some colored water, containers of different colored water, and have them experiment with different colors. They could just drip it onto the carnations. But also, I would give them some tools to take apart the stems. And so if we're trying to figure out how these stems act like straws, I would let them just tear them apart. I would get them tweezers and tongs and magnifying glasses. I would give them ice cube trays to sort things into. I would give them things to draw what they see. You have to make sure it's hands-on, at least 3 to 5 activities, and enough to do to test things out. Not just one thing, not just stick it in, change the color, walk away. Let's give them multiple things to do. Let's play with the color. Let's tear apart the stems. Maybe I could even do some rubbings of the stems to do some crayon rubbings on top of it. From a smaller person, I would talk about how it feels. Mine are very wet and very smooth. So I would have these in a science table and have them be able to touch them and feel them. If your classroom does not have a science table because they're too little, this is really a cool activity at the table. Again, touch them, feel them, smell them, talk about them. I wonder how the flower got its water up into the petals. I wonder how that happened. Narrate for little guys and let big guys talk. So what about things like STEAM and STEM? You've heard about things called STEAM and STEM, and some of you would know what they are, and some of you have no idea. So basically, STEAM and STEM are acronyms for cool things you can do with science. S is for science, T for technology, E engineering, A art, and M math. Because we know that science is integrated, not just 10 seconds of the day, you can integrate so many cool things together. So in this example, I have some simple things. I have some salt and some food coloring, and I mix it in this bowl a little bit here. And I have my handy dandy ice, and of course, the medicine dropper. Now, STEAM does not even take into account all the great fine motor things that are involved in some science projects. So if I could demonstrate this kind of thing at a circle time, basically to show kids how to use the materials. But I still don't want to answer any questions. I want them to do the investigating. But I might need to show them how to use a pipette. So you need to squeeze first, put it in, let it go. Not all kids know how to do that. So I would talk about all the science process questions. So I would show them here. This is going to go to a learning center, but I would show them at a circle time first. So first I'd say, I wonder how we could get this ice to melt. Anybody have any ideas? We could observe it, we would feel it, smell it, listen to it. We're gonna make a guess of how we can get this ice to melt. Someone might say, put it in the oven, put it in the microwave, cook it, leave it outside. All kind of cool ideas. And then you get to test it out. You could leave all the testing for a learning center or demonstrate it here. I have some salt water and I want to figure out if this will help me to melt my ice. And this is kind of cool because this involves the A and STEAM, the art. You can make some really cool color mixtures. I just did a little bit of red. It's very hard to hold the camera while I'm doing things. So there's some red here. I could use this as some really neat color mixing too. Just be pretty patient with this. So the little guys can spend some time trying out how to get this ice to melt. So we're gonna talk about it, we're gonna test it out, and we're gonna talk about what do we notice, what do we see, and try it out again and change something. If this was at a center, I could have things like salt water, regular water, I could have baking soda water, I could have Sprite, I could have different liquids to try to figure out what will melt the ice. And so that process is there again. I wonder, I observe, I make a guess, I test it out, talk about what I notice, and then try it out again. But it's so important, there's lots of opportunities to try things out when you put things in a center. We don't just want to make one way to do things, we want them to test it out, because they're gonna have better ideas than we do. There are so many different facets of science. So you have some things like chemistry. You have some types of life science where you'll pick out plants. You also have physics. Now you may think I have lost my mind, but you can do really cool physics things in early childhood science, and you're already doing it. So in this very lame and hard to film example, we're gonna be building some ramps. And the science content, the science standard, is actually an early childhood standard in physics called Forces in Motion. And this is in infant toddler standards, which is infants, toddlers, and youngest preschool, as well as the preschool standard. So even in the infant room, you're doing really cool science. So here's how this might look. In the infant room, I have just this kind of cool ball here, but any kind of ball will do. In the infant room, you might talk about fast, slow, fast, slow. And you would roll the ball back and forth. Miss Donna's rolling the ball to Megan. Megan can roll the ball to Miss Donna. Miss Trudy rolled the ball to Graham. Graham is rolling it fast. And Maddie is rolling it slow. And you'd be overemphasizing the fast and the slow of the ball. So that's a forces of motion when you talk about things that are fast, things that are slow. Just that simple in the infant room. In the toddler room, you could do similar things, but you could start building some ramps, some small ramps out of Legos or Duplos. My big ramp is out of a lid. But in the toddler room, you could start adding some ramps in there. In youngest preschool, I would do a same activity, and I would roll the ball, and I would narrate again. I'm rolling it fast, I'm rolling it slow. And I would definitely try some cool ramps in youngest preschool as well. You could add ramps with lids like this. They could build their own with blocks. And I would ask them questions. Why is this ball fast and why is this ball slow? In preschool piece, I would roll the balls down ramps, but also add some different textures. I'll try to show that to you. So my ramp is made out of a plastic lid. And if I was in preschool piece, I would add some more texture on here. I could put some foil, I could put some fabric or some cotton or a blanket, try different kind of balls, add more variables. And if I was in Love and Joy, I would have them write about it and draw about it. This example is going to be in your handout, but physics is really simple to do, and you're already doing it.